Okay, all right. So, I think we should start now, right? So today we are going to continue our lesson related to population ecology, and to finish this chapter, inshallah, within maybe 1.5 hours. Okay, plus few exercises. All right. So, back to the discussion on this chapter, population growth. Okay. So remember, previously we have discussed about a few terms related to population ecology, right? Like natality, mortality, okay? Change of population, right? How to calculate, what are the formulas, okay? So you have to remember all the formulas since the formula will not be given in the exam, right? So remember back, there are few formulas that we have discussed earlier. So ingat, the first formula that you have to remember is the growth rate, right? Growth rate given as R, okay, equals to B minus D plus I minus E. That is the first formula, okay? Second formula is the change of population. Formula for change of population, okay, given as dn over dt equals to Rn. Okay, where R is the growth rate and N is the population size. All right, so this is the formula. So this particular formula somehow related to the population growth. Okay, because some of the formula will be derived as we learn about population growth curve. So, okay, and please remember again, for the first formula, growth rate R equals to B minus D plus I minus E. All right, kena tengok soalan. If the question already give you in the form of rate, so you don't have to divide into the population size. Tak payah dah, right? But if the question does not give you in form of rate, okay, it just mentioned about this is the number of death and this is the number of birth in in this amount of population size. So you have to get the rate by dividing the birth and the death to the population size. Okay, right. So we are going to see that later. Okay, now let's go to the population growth curve. Atau bahasa Melayu kita kata lekukan pertumbuhan populasi. Lekukan pertumbuhan populasi. So there are two types of population growth. So please remember, if the question is related to population growth curve, right? The answer is just only exponential growth curve or logistic growth curve. Okay, exponential means the population will grow in a J-shaped form. J-shaped growth curve. And for logistic, the population will grow in a S-shaped form. So thus we also call it as S-shaped growth curve. Okay, right. So what is explained by the exponential growth curve? So exponential growth curve shows accelerating increase in the population size. You can see from this picture itself, okay, the curve is exponentially increase into a J shape, right? So this kind of growth of a population happen in ideal unlimited environment. Apa maksud unlimited environment in this case? Abundance of resources, right? And no competition. Itu maksud a kind of environment that is ideal, right? That is optimum or with unlimited environment. So this refers to an environment that have abundance of resources, right? No competition at all. So population will grow in exponentially. Okay, right. Whereby for logistic growth curve, kenapa logistic growth curve population akan naik and suddenly dia akan jadi S, somehow like dia jadi level of like this. level off. Dia jadi constant macam gitu. Kenapa? Right? So this kind of population growth, right, is slow down, okay, due to limiting factors. What are limiting factors? Of course, limited of resources. Okay, limited space, limited water, limited mates, and many others. So these are what we call as limiting factors. Okay, and the population will level off at carrying capacity. Level off means dia jadi constant as it reach to the carrying capacity. What is carrying capacity? So I'll explain later. Okay, right. Next. Now let's see the exponential growth curve in detail. Okay, right. So exponential growth curve, also known as J-shaped growth curve. So in exam, you can use this both term, exponential growth curve or J-shaped growth curve. Okay, right. So remember, population can grow under optimal condition, meaning in the absence of limitation. Ingat balik, what is absence of limitation? Meaning the abundance of resources. So the population start out slowly. I mean, the population growth start out slowly, as you can see from here in this picture of elephant population growth. So the growth started out slowly, right? And speed up as population increases. And you can see, and the growth will speed up as population increase. Okay, so does population grow at its intrinsic rate of increase, or we call as biotic potential. So this population or the J-shaped growth curve of population will grow at its biotic potential. What does biotic potential or Rmax? It is maximum increase of number of individual per unit time under optimal condition. So in other words, biotic potential means maximizing the increase of population size, increase of population size. All right. Or in other words, maximizing reproductive success. All right. So it's due to abundance of resources, so they will grow at the maximum rate, in other words, lah. All right. To maximize the number of individual under this optimal condition. Okay. So that is J-shaped curve. Okay. Now back to the picture of elephant apa nama, population growth. Right. So the growth of elephant showing J-shaped growth or exponentially growth. Why the process ataupun the growth of elephant start out a little bit slow at the early 90th centuries? 1900, 1920, 1930 sampai 1940 ni. What is your opinion? What makes population of elephant a little bit slow at this early of 90th centuries? Any idea? Agak-agak you. 1940, 1920, ada apa waktu tu?
Musim ngawan, madam.
Musim mengawan. Sekarang kita tanya kenapa, why it start out slowly. Slowly. Ha? Tak boleh dengar. Tak apa, boleh type juga. I want to hear your answer. Why the population of elephant start out very slow pada awal tahun 1900 sampailah 1940? What would be the possible causes? We are talking about the elephant growth worldwide. Yes, one of the factor is due to illegal hunting. What else? Because during this particular time, the what you call it, rules and regulation is not really kata apa, emphasizes, not really implemented, kan? Okay, what else?
Disease.
Penyakit, madam.
Okay, disease spread, maybe related. Lagi? Ni, 1920, 1940.
World War.
War. Okay, World War. So war is not just affecting human, it also affecting animals, right? As a whole. So we can say that these are few factors that might contribute to the slow increase of population growth in elephant, right? So due to illegal hunting, war, right? So no rules that orang kata apa, definite rules related to illegal hunting and whatnot. But as you can see, after 1950s onward, population of elephant increased rapidly due to maybe law enforcement related to hunting, and then war has stopped, right? And whatnot. So these are what can be explained with this kind of curve. Okay, right. Okay, next we go to the formula. So you can see for J-shaped growth curve, all right? So the formula related is change of the population size is dn over dt equals to Rn, where remember R is the intrinsic rate of increase and N is the population size. Okay, right. So next we go to the logic of J-shaped curve. Okay, J-shaped curve will always be limited, meaning there is no one or there is no any population that can keep on increasing exponentially, right? Sampai bila-bila. Tak ada, right? Meaning to say at one time, the population also will be slowed down, right? The population growth will be slowed down and limited, right? So maksudnya, there is no population akan keep on increase sampai bila-bila. Tak ada. At one time, the population must be encountering environmental resistance or environment limitation. Mesti. And thus, from J, later on, it will become S, right? So J shape will change into S-shaped curve due to limiting factors or environmental resistance. Okay, right. Thus, we have the second curve, the logistic growth curve or S-shaped growth curve. Right, you can see here, the formula is already changed, modified. dn over dt equals to Rn, k minus n over k. Why? Because we are considering the concept of carrying capacity of an environment, carrying capacity. Okay, apa maksud carrying capacity? Okay, I will explain to later. Okay, all right. So, why the curve, right, forming an S shape, right? So the population is slowed down, population growth is slowed down due to limiting factors. So remember, there are so many limiting factors like nutrient, food, spaces, kan? Like water, limitation of mates, whatever. Okay, so for small population, right, the growth will be exponential. Let's say dalam satu URA ni ada 10 orang je yang duduk dalam satu URA ni. So population will increase exponentially because there are a lot of resources that can be utilized. Okay, but there is a steady decrease in the growth as the population encounter environmental resistance like tadi limited resources, lagi apa, competition, whatever tu semua kan. Okay. And etc. Okay. So as population encountering environmental resistance and also approach the carrying capacity, then the population growth will be slow down and later on level off. Okay. Okay, right. So exponential equation is modified by a term that represents the overall effect of limiting factors, k minus n over k, where k is carrying capacity. Okay, what is carrying capacity? Carrying capacity is the maximum number of individual that can be support or sustained for an indefinite period of time by a particular environment. Meaning to say, right, I give you an example. Let's say CFS IIUM can accommodate, right, a maximum of 4,500 students by what I call it, by take into consideration of the bed, the rooms available, okay, 4 per room, katil, meja, classes, okay, meja dekat kelas, cafes. So by looking at all these resources that are available in CFS can accommodate up until 4,500 students. So that is the carrying capacity for UIA. Okay, in case CFS, okay, receive 5,000 students, okay, you just imagine what will happen, right? Class will be cramped, room will be not 4 per room, it can be 6 per room, right? Cafes will be outsources, okay. Apa lagi? Toilet lagi panjang you beratur, right? So these are all the effect if population grow above or beyond the carrying capacity. Faham Itu maksud carrying capacity, maximum number of individual that can be sustained or support by an environment, right? With that particular or at that particular time. Okay, right. Okay, so okay, the formula has been modified to dn over dt equals to Rn, k minus n over k, where k minus n is the number of individual that still can be supported or accommodated by the environment. Contoh macam tadi, carrying capacity of CFS IUM is 4,500. Now, your batch student dalam lingkungan 3,500 contohnya. Right, so what is the balance number of individual that can be supported by all the resources that we have in CFS? So you just tolak lah. So ada berapa lagi? 1,000. So actually we can still accommodate 1,000 students. Right, so that is K minus N. Okay, and K minus N over K is the fraction of carrying capacity that can still available, right, for the population growth. So the fraction, kita bahagikan dia. Okay, nisbah dia. Alright. Okay, now effect of K minus N over K on the growth rate. Assume the carrying capacity of an environment is 1,000. Sesuatu environment tu carrying capacity dia 1,000 je. Okay, when population size, which is N, is small, like 10 for example, so dN over dt equals to Rn, K minus N over K. K 1,000 minus 10 divided by 1,000, you can have 0.99. So the population is actually can grow exponentially because the value is close to 1. Okay, lagi dekat dengan 1 maknanya what we call it, the population can grow exponentially, means you have abundance of resources. Masih lagi banyak resources yang ada. You have ample of resources sangat-sangat banyak, right? And it can still accommodate high number of individual. Okay, right. So, but when your N is large, your population size N is large. Remember, carrying capacity 1,000 and the population size is 1,000. So the N over dt equals to Rn K minus N over K. So this fraction you will get 0. 0 here means you already reached the carrying capacity. Dah sampai carrying capacity. So ni lah limit dia. Dia dah sampai 1,000. Okay. So what happened? Population will level off. Level off. Ni dia akan jadi level off. Stagnant macam tu. And logistic growth curve become S-shape. And after leveling off at carrying capacity, usually population will fluctuate slightly above or below carrying capacity. So after leveling off, usually population size will slightly macam tu. Okay, fluctuates above or below carrying capacity. So soalan pernah keluar dan tanya, dia bagi you gambar macam ni and dia tanya you determine the carrying capacity. So macam mana nak kenal pasti how to calculate carrying capacity, because the population growth is fluctuating up and down the carrying capacity, right? So salah satu cara tengok dekat mana titik yang, contoh kalau macam ni, majority of the points is somehow straight macam tu kan. So you can get this point. So this point is your carrying capacity. Or if the curve is fluctuating macam ni, right? So this is the peak and this is the lowest peak of the fluctuation. So take the middle points. So that is your carrying capacity. Okay? Right. So that is, later we will look into few exercises. Okay. Maybe ada juga soalan yang related to this carrying capacity. Okay. Next. All right. This is another important picture. So hopefully you can get this picture, right? And paste it in your note. Okay. Right. So this picture combining both J-shaped growth curve and S-shaped growth curve. You can see that for S-shaped growth curve, population start to slow down at this point. And this point, it's already reached carrying, sorry. And this point is where the population growth is already reached the carrying capacity. Given to you, the carrying capacity of this population is 1,500. Right? So this is the calculation K minus N over K, right, for S-shaped curve. Okay. All right. So far, any question?
Tak ada, madam.
Okay. All right. Next, we have looked at what is J-shaped curve, what is S-shaped curve. Okay. Now let's go and look at what are the factors that can limit population size and population growth. Apa faktor-faktor yang boleh menghadkan pertumbuhan sesuatu population. Okay. So the factors that can limit population size and growth divided into two. Right. So ingat keyword. Factors limiting population growth. Kalau tadi growth curve ada dua, population growth curve, logistic or exponential. Now population factors that limit population size, population growth or population distribution, also divided into two. They are density dependent factors and density independent factors. Okay, density dependent factors are those factors that depend on density ataupun kepadatan. Makna kalau population tu sangat-sangat padat, these factors will contribute to the limitation of the population size. Okay, right? Number two, density independent factors are those factors that not depend on density. Maknanya dia tidak bergantung dengan sesuatu dengan kepadatan populasi tersebut. Populasi A ada 5, populasi B ada 50,000 individual. But when this factor happen, contoh fire, forest fire for example, so kalau berlaku pembakaran hutan, tak kisah dalam hutan tu ada 50 ekor binatang ke, 50,000 ekor binatang ke, the effect is still the same. It will cause limitation in population growth. Dia akan menjejaskan pertumbuhan sesuatu populasi. Faham Right? So, now let's go to density dependent factors. Explanation. At low density of a population, there is a little effect on the population growth because there are still abundance of resources. But as density of a population is become higher, negative effect can be shown, right? Where the population growth will slow down and stop at carrying capacity. These are due to limited of resources, overcrowding, disease spread, and etc. Okay. As for density independent factors, so density independent factor does not depend on the population size, okay, or density. It will give the same effect on population. For example, forest fire. Forest fire will kill 80% of fauna, whether the forest having 50 or even 1,000 individuals. So effect dia tetap sama. Okay, right. Now let's see the density dependent factors. So there are 7 density dependent factors. 7. So please remember all the 7 with explanation. Okay. Number 1, right? Density dependent factor is competition for limiting resources. So the limiting resources that we mention here is number 1, food, nutrient, water supply. Right? So when a population is having limited of nutrient or resources like food and water, it will not, the resources that available will not enough to supply for all. So some individual might use more than other individual. So bila berlaku benda macam ni, ada orang guna lebih, ada orang guna sikit sangat. So this will lead to competition. Alright. So there are 2 types of competition. Inter-specific competition and intra-specific competition. So inter-specific competition is competition among individual of different species, whereby intra-specific competition is competition among individual of the same species. And intra-specific competition is more intense. Kesan dia lebih teruk lah, because the need of organism are the same. Okay, right. Okay, example over here. You have here y-axis is the average number of seed produced, jumlah biji benih yang dihasilkan, versus number of plant per meter square. Okay, so let's say you have here 1 meter square of tanah, right? And dekat tanah ni ada 5 pokok. Okay, 1, 2, 3, 4, 5, for example. So when this meter square of plant only contain 5, what you call it, 5 plantain, okay, so the average number of seed produced by the plants around 5,000 seeds. 5,000 seed if there is only 5 plants per meter square. But you can see that when the number of plants increases, like here, ni berapa ni? 50 lah contohnya. Within this, the same size of meter square, you have 50 plants, for example. Right? So the number of individual increase and you have a limited of resources, which is here, nutrient, water, space, and whatnot. So the number of seed produced by the plant reduce. Dalam berapa tu? Maybe 500 contohnya, 500. Nampak tak? So that is the effect of resources towards the average number of seeds produced. Okay, so that is example. Okay, next, the song sparrow. This is average clutch size. Average clutch size means the number of offspring. And this is female per unit area. So in 1 unit area, if the female is around 20, song sparrow female, so the average clutch size is around 3.6. Anak-anak yang dia boleh menetaskan ataupun yang menetas daripada telur, dia boleh bertelur dan menetas dalam 3.6 ekor. But if the number of female in unit area increase to 70, for example, you can see that it actually affecting the number of clutch size. Okay, so that is the effect of what we call it, limiting resources. Okay, right. Okay, number 2. Competition for limiting resources. Number 1 is food, nutrient, water. And number 2 is competition for light. Okay, so as plant density increases, plant that do not get enough light will not grow enough and might die. So logic lah, competition for light. Okay, so and space, overcrowding or high density population, right? Bayangkan kita pergi tengok cerita ataupun kita tengok dokumentari slumdog area dekat Indonesia or dekat India, slumdog area. So they have a limited spaces, but they have a lot of people living in that particular area. So they have limited of space. So overcrowding can cause diseases and stress, and also depleting of resources. So these are all related to factor number 1, competition. Okay. Factor number 2 is parasitism. Okay. High density population will cause parasite to spread easily. Right? So senang parasite untuk berjangkit. Okay. So jadilah nanti banyak-banyak penyakit that related to parasite. Okay. So parasitism also related to diseases and health. So high density population size can cause disease to be spread more readily because they are living very close together. Right? So high chances of disease that are caused by direct contact, right? That spread among the population in high density. Even plant that living in crowded condition will be small, right? Less robust and less likely to survive. Less robust here is not really strong lah, tak berapa kuat, right? And they are not having high chances for survival. Okay, and next factor number 4 is predation. Okay, predation is important in controlling population. So usually the number of predator will increase as the prey increases and vice versa. So this predation can be seen in the relationship between lynx and snowshoe hare. So lynx ni, this is lynx and this is snowshoe hare, right? So lynx ialah kucing, kind of a species of cat in the North Pole, okay, right? Okay, so you can see here in winter, right? Usually, when the population size of snowshoe hare, which is the prey, mangsa. Apabila percentage of mangsa meningkat, of course, the population of lynx also will increasing. Sebab makanan ada. So, predator pun akan meningkat. But when the snowshoe hare population drop, the population of lynx also will drop. Okay, so this is what we call as relationship between predation lah, in predation. Okay, untuk. Okay, next. Okay, accumulation of waste product and toxin. So high concentration of toxic metabolic limit population growth of certain organism even when food is plenty. Okay, so high density population usually will produce a lot of waste. Kita tengok je slum dot area, sampah merata-rata. Okay, so accumulation of waste and toxin, right, can limit population growth. Okay, next, territoriality. Territoriality is a well-bounded physical spaces that protecting resources within it. So every individual have their own territory. Even when you sit beside your friend also, you have your own territory, your own space, right? So territory is very important for each individual. But when population is very high density, so territoriality, or in other words, physical bounded spaces will be limited. Okay, example, bird, establish breeding territory, which defends again intruder and limit population dan density. Burung nak bertelur pun dia perlukan dia punya own territory, right? But if the space ataupun the territory become limited, so it can actually affecting their nesting behavior. Okay, all right. So this is example of marking territory lah. Right. Okay, you can see that this bird exhibit their own territory in nesting behavior. Nampak tak? Setiap antara diorang ada space yang boleh kata lebih kurang sama. Okay, so that is their territory. Okay. And factor number 7 is intrinsic factor, faktor dalaman. So living in overcrowding environment can cause stress. Kan? You just bayangkan bilik awak 4 orang, tapi ada lagi 4 orang squatting kat bilik awak. Kan? So you akan rasa tak selesa. So overcrowding can cause stress syndrome that lead to abnormal behavior. So this abnormal behavior also can lead to hormonal changes, right? Somehow can cause affecting the maturity of sexual development. Okay, thus will decrease birth rate and also suppressing immune system, which will increase the death rate. So these are factors that related to density dependent factors. Ingat dia berkadar kepada kepadatan. Kalau population size is very high density, this factor can lead or limit population growth. Okay. Right. Okay. Next, we go to density independent factors. So density independent factors ada 3 sahaja. Remember, it does not depend on density, regardless of the size of population. When these factors happen, it somehow can limit population growth. They are, first, weather. Okay, unfavorable weather can limit breeding success or cause mortality during non-breeding season. For example, winter mortality of snowshoe hare. Ingat tadi, snowshoe hare tu during winter sebab dia putih kan, biasanya high survivor lah waktu winter sebab dia putih, so they can easily escape from the what you call it, linex, right? So population of snowshoe hare will increase in winter. But as seasonal changes, right? So dah jadi waktu tukar season pula, population of snowshoe hare will drop. Right? So somehow weather can affect population growth. So weather also responsible for boom and bust cycle. So this is what we call as boom and bust. Boom is when the population increase exponentially, right? But bust, it is sudden decrease in the population size due to factors like weather, okay, shelter and whatnot. Okay, so ni kita panggil boom and bust. Okay, factor number 2 is human activities. Pesticide and pollutant cause drastic decline in natural population. For example, pesticide, DDT, right? So DDT is a kind of pesticide. So this pesticide drastic reduce of population of predatory bird, such as eagle, osprey, pelican, right? So this pesticide also cause destruction of habitat. Okay, human activities also cause destruction of habitat and eliminate large number of species, and sometimes can cause one species to the brink of extinction. Okay, right. So factor number 2, human activities. And factor number 3 is natural disaster. So natural disaster is periodic disturbances, right? Like volcanic eruption, flooding, storm, fire. So when this natural disaster takes place, it can also cause extreme fluctuation and changes of population growth and size. Okay, so these are density dependent and density independent factors. Any question so far?
Faham, madam.
Boleh? Okay, right. Okay, baru 17. Mana lagi orang lain tak ada? Please write down your name in the chat box for attendance, okay? Okay, sambil-sambil writing down your name in the chat box for attendance. Next, we go to another term, another concept, right? On survivorship curve. Okay, survivorship curve. So concept number 1, we have looked at population growth curve. Concept number 2, we are looking at factors that limit population size or population growth. Okay, now we are in the third concept, different concept. Make sure you're not confused, right? The third concept is survivorship curve. Okay, population growth curve ada 2, factors limiting ada 2, survivorship ada 3. Survivorship growth curve. Okay, right. So, what is survivorship curve? Okay, let's see here first. Survivorship means percentage of original population that survive to a given age. So that is of survivorship. So survivorship curve is the curve that showing proportion of individual alive at different period of the total life span, or the actual number of survivor or percentage of survivor plotted against time, which is age. So you can see y-axis is the number of survivor, usually number or percentage, and the x-axis is age, usually age refers to age. You can see example of this organism, Belding squirrel, right? So this Belding squirrel, you can see the number of survivor is actually decreasing constantly over age, right? Maksudnya the number of survivor dia not really depending on age. Dia elok je lah constant, right? As the age increases, the number of survivor decrease constantly. So this is for Belding squirrel. Okay, so this is what shown by the survivorship curve. Okay, another example, right? A table of the Belding squirrel yang tadi tu, inilah dia. From age 0 until age 10. And this is the number of alive or survival. So you can see that the number of survivor at early age is higher and it reduces constantly over increase of age. Okay, so itu maksud dia. Okay, so there are 3 types of survivorship curve, right? Type 1, type 2, and type 3. So please take note on the way of writing the survivorship curve. Type 1 survivorship curve, type 2 survivorship curve, and type 3 survivorship curve. Alright, and you can see the shape. Look at type 1. Kita tengok this is number of survivor and this is age. You can see that for type 1, high number of survivor, right, from start of the early age until 50s. Maksudnya there is high rate of survivor at young age, and most of mortality, right, or high death rate happen due to senescence, disebabkan oleh penuaan. Kematian berlaku banyak disebabkan oleh penuaan. So that is explained by type 1. Okay, so let's see one by one. Okay, type 1 survivorship curve. So type 1 survivorship curve is known as late loss curve. Late loss. Apa maksud late loss over here? Late loss. Tengoklah gambar curve tu. Apa maksud late loss? Higher rate of loss ataupun death that happen at later age. So this is what I call as late loss curve. Okay, right. For type 1 stated that young age usually has high survival rate and most mortality happen at the age of or due to senescence, penuaan. Maksudnya tua lah. Maksudnya umur kematian banyak ataupun tinggi kadar kematian pada umur-umur yang agak tua. Okay, right. So usually organisms that have type 1 survivorship curve living in stable population size. Okay, stable population size meaning that the growth curve is usually logistic growth curve. Ingat balik macam mana rupa logistic growth curve? Macam ni. Stable environment means this environment living at the population that near or reaching the carrying capacity. Okay, what are organisms that have this type 1 survivorship curve? They are human, whale, elephant, lion, tiger, usually bigger organisms or bigger mammals. Okay, so these are type 1 type survivorship curve. Okay, type 2. Okay, type 2 yang ni. Ni type 2. You can see the example over here. The Belding squirrel. Okay, type 2. Type 2 survivorship curve is known as constant loss curve, right? Where it shows relatively constant death rate throughout the lifespan regardless of age. So constant, kadar kematian constant. Okay, right. Example of organism that have type 2 survivorship curve are jellyfish, hydra, coral, balding squirrel, rodent, right? Honeybees and many reptiles. So these are some examples. Okay, walaupun rodent you nampak mammal, tapi rodent dia duduk dekat type 2 survivorship curve. Okay, by looking at nature of their living. Okay, right. Okay, dah salin?
Madam. Rodent tu apa?
Rodent tu adalah sejenis macam tikus tapi besar lagi sikit.
Oh, okay.
Okay, done copy?
Dan
Okay, next type T pula dah. Type 3 survivorship curve. Okay, type 3 survivorship curve is known as early loss curve. Okay, any idea what does it mean by early loss? Tadi late loss, type 1 late loss. Ini early loss. Okay, look at again the curve. You can see the curve is like this. Meaning to say, you can see that the number of survivor for early age is very, very low. Kan? Umur-umur awal ni number of survivor dia sangat-sangat rendah. Okay, so that is what we call, it is known as early loss curve. Okay, right. So, there are vast number of offspring produced. Characteristic for organism that have this type of survivorship curve is vast number of offspring. Okay, so dia tahu yang dia punya survival rate of the juvenile, of the young will be very, very low. Dia tahu yang kadar survival akan sangat kurang untuk anak-anak dia. That's why organism ni will produce a lot of offspring. Kalau dia bertelur tu, dia bertelur thousands or hundreds of eggs because they know that most of the young will be die at the early life. So we call it as high juvenile mortality. And there are only small number of survivor that will survive to a reproductive stage. Usually this kind of organism living in unstable population size. That is open with predation, sangat terdedah kepada predation and so on. Okay, example of organism with this type of survivorship curve are oyster, some plant, fish, parasites. Okay, so these are type 3 survivorship curve. Campur lagi insects. So insect also have type 3 survivorship curve. Okay. Okay, done copy?
Madam, kalau turtle?
Turtle type 2.
Oh, okay.
Okay. So you don't worry because we are not going to, kalau soalan keluar exam, the question will not give you example that is away from whatever that you learn. So kita akan bagi contoh-contoh yang dekat-dekat dengan apa yang kita belajar sajalah. Right? Because if you want to list out all animals punya survivorship curve and which category of survivorship curve that they are belongs to, panjang cerita dia kan. Okay. Okay, done copy?
Done.
Okay. All right. Next we go to, right, the K and R strategies or K and R selection. Okay. So this subtopic of K and R selection related to survivorship curve. Dia berkait. Okay, right. So distinguish between R and K selection. So the word R over here and K over here somehow can give you idea what kind or what type ataupun what are the characteristic or strategies used by this organism. So R here, remember R means rate. Betul tak? Right? We dalam rumus tu dn over dt equals to R, and so R is actually intrinsic rate of increase. Kalau ikutkan J-shape curve. Intrinsic rate of increase or biotic potential. Right? Maximizing biotic potential. So R. And K is referring to carrying capacity. And this kind of curve usually adalah curve yang S is shape curve. Kan? Okay. So now we are going to see what kind of organism that use K strategies or selection or R strategies or selection in order to ensure the survival of their kind. Right? So what are the strategies that chose by them in order to ensure survival and increase in rate of population? Okay. So before that, let's go to the definition. Okay. So selection for trait are sensitive to population density. Sensitive to population and density and favored high densities is known as K selection, whereby density or density dependent selection. In contrast, selection for trait that maximizing reproductive success, which is R, in uncrowded environment are called as R selection or density independent selection. Okay, right. Okay, next. Okay, life history refers to traits that affect an organism reproduction and survival success in environment. K selection is selection of life history that advantages at high population density, which near to the carrying capacity where competition among individuals are or is stronger. Whereby R selection is selection for life history that maximizing reproductive success at low density or uncrowded environment. Okay, so this concept represents two extremes in a range of actual life history. So K selection or K strategies usually favors ataupun biasanya a kind of strategies or selection used by organism that living in a high density population, right? And whereby R selection or R strategies are those strategies that used by organism that living in unstable environment, right? Low density population size, and they are maximizing their reproductive success. Okay, so now let's look at this one. Okay, yang penting kat sini sebenarnya, these are the K selection or K strategies. And this is R selection or R strategies. Okay, semua strategies ni kena hafal. 14 ni kena hafal sebab dia boleh keluar soalan essay dan tanya awak explain, right? Apa nama? 5 ataupun give explain 5 K selection and R selection mungkin, right? So you have to know what are the K selection or K strategies and R selection. Okay. Cara nak ingat, kita kena buat cerita. Alright, so paling tidak 5 kena ada dalam kepala. So buat cerita dulu. Okay, look here. Okay, contoh. K selection, alright, this is R selection or R strategies. Okay, so K selection strategies or organism are usually deer, lion, human. Okay, dapat satu dah. Kena ingat example dulu. Deer, lion, human. Deer, lion and human have type 1 survivorship curve. Ingat tak tadi? Kita dah belajar survivorship curve. right? Deer, lion, human, elephant, tiger, alright? So they are lies in type 1 survivorship curve. Okay, right. So dapat satu dah. So type 1 survivorship curve individual or organism like deer, lion, human, horses, semua tu, they are large size organism. Kan? Saiz besar. Organism yang bersaiz besar. So bila organism bersaiz besar, biasanya they have long life expectancy. Jangka hayat hidup dia panjang. Okay. So when they have long life expectancy, so do they need to mature rapidly? Tak perlu, right? So since umur dia panjang, so they are having late maturity age. Jangka hidup ataupun umur untuk sampai tempoh matang adalah agak lambat. So they have late maturity age, and they also have long period of embryonic development. Disebabkan jangka hidup dia panjang, dia lambat matang, maka tempoh untuk dia embryonic development, maksudnya tempoh kehamilan haiwan-haiwan ni pun ataupun tempoh dia itulah apa orang panggil kalau manusia mengandung lah kan. Okay, so the embryonic development period is also long. Okay, so you dah dapat berapa dah kat situ? Right, long embryonic development. Okay, next, they also able to reproduce throughout their lifetime, right? And living in stable environment that reach or near to the carrying capacity. So near to carrying capacity means they have logistic growth curve. Okay, next, they are restricted where they live. Maknanya dia tak berpindah randah antara satu dengan tempat yang lain. Thus, they are known as ecological specialists. So they are utilizing whatever resources that they have there in their environment. Okay, alright. Next, since they are what we call it, how to say tadi living in the environment that near to the carrying capacity, right? So kita kena faham resources somehow akan jadi limited. So due to that, they will just produce few offspring sahaja and providing substantial care of the offspring. Dia melahirkan anak yang tak berapa banyak, tetapi dia akan jaga betul-betul to ensure the survival of dia punya anak-anak. Alright, so that is and they are usually limited by density dependent factors sebab they are living in an environment that near to the carrying capacity. So faktor-faktor penghad untuk this kind of environment ialah density dependent factors. Okay, so that is somehow what I can help you to memorize. Okay, buat cerita. Okay, these are the strategies of case selection organism. These are their selection in order to ensure their what you call it population growth. These are their strategies. Okay, as for our selection, right, our strategies, remember this kind of organism trying to maximizing their reproductive success. Okay, so usually they are going to produce many offspring. So maximizing reproductive success maknanya dia akan hasilkan anak yang banyak, bertelur dengan sangat-sangat yang banyak, and they are not providing any parental care. Dia tak akan jaga, bertelur banyak-banyak tinggal, right? Sebab dia tahu somehow among these hundreds or thousands of eggs akan ada yang tak survive, banyak yang tak survive, right? In early age. That's why they have usually lies in type 3 survivorship curve. Siapakah organism tu? They are grasshopper or insects. Ingat tadi, grasshopper or insects lies in type 3 survivorship curve. Okay, right. So, apa tadi? Okay, this kind of organism like grasshopper or insect usually have short life expectancy. Jangka hayat hidup dia pendek. So, bila jangka hayat hidup dia pendek, dia kena cepat mature. So, they are going to reach early maturity and have short period of embryonic development. Sebab semua kena cepat, sebab jangka hayat hidup dia pendek kan. So kena cepat matang, kena cepat tempoh raman telur pun kena tak lama, right? And dia akan produce a lot of telur lah, offspring, because they are reproduced only once in their lifetime. Most of the insects that example here. Okay, right. So the grasshopper insects are small in sizes. Size diorang sendiri pun kecil. So they are living in unstable environment and widely distributed. So dia sana sikit, sini sikit, sini sikit, sini sikit. So they are known as ecological generalists. And what kind of growth curve that do they have? So biasanya R selection, right? Remember formula dia, the end of over dt equals to R max n kan? Alright. So they have exponential growth curve. Alright. That do not reach carrying capacity and sometimes responsible for boom and bust. Dia boleh jadi boom and bust cycle. And thus, they are often limited by density independent factors. Okay, right? So that is the R strategies or R selection. Okay, to apply the knowledge, cuba tengok kat sini. Example. So this is the description of two different organisms. You have to choose which one using the K strategy or K selection, which one is the R strategies or R selection. Okay, A. Brazilian nut seed produce a moderate number of large seeds that provide a large store of energy that will help the seedlings become established. B. Dandelion produce a large number of small seeds, ensuring at least some of them will grow and eventually reproduce. So, between A and B, which one is K strategy? Okay, Fatihah kata A. Yang lain? Yeah, correct. So, Brazilian nuts, what is the keyword that you can dapat from here? What is the keyword yang you dapat from this statement?
Moderate number of seeds.
Yes. Moderate number of large seed. So that is the keyword, right? Because K strategy, one of the K strategy, ingat tadi nombor berapa tadi tu? Number of offspring dia tak terlalu banyak. Okay, whereby dandelion is the R strategy because you can see it produce large number of seeds, right? Itu memang characteristic of R strategies or R selection. Okay, all right. Any question? Any question? Tak ada. Okay. Kalau tak ada soalan, then you can see last but not least, in Quran, there are few verses that Allah mentioned about corruption. Do not do harm. Share everything that you have with the world. Okay, do good and so on. For example, in Surah Al-Qasas, Allah mentioned that do not forget to share the world. Do good as Allah done good to you and desire not corruption in land. Indeed, Allah does not like corruptors. So because we know that corruption has occurred on land due to human acts itself. So we are actually now tasting the effect of our own act. So which can cause the population to be affected as a whole. Kan? Okay. In another verse, Allah mentioned in Surah Al-Baqarah, okay? And eat and drink from the provision of Allah and do not commit abuse on the earth and spreading corruption. So whatever that we do, kita kena make a way how to replenish it, right? So to sustain it for future. Okay. Another verse, sama juga Surah Ar-Rum, corruption has appeared throughout the land. Okay. And people have earned, so he may let them taste part of the consequences of what they have done. Okay, so macam itulah supaya kita dapat kembali kepada Allah. Okay. Alright, so that's all that Mark finish off chapter 12. Okay. Any question before we go to exercise? Tak ada. Okay, kalau tak ada, then I will share with you exercise. Hmm. Okay. Ramai tak masuk kelas. Okay, I will start with a few questions related to chapter 12 ni. Okay. So, jot your own answer and let's discuss together. So, please unmute your mic to answer together with me. Okay, soalan yang pertama. Which of the following is the characteristic of population exhibiting type 1 survivorship curve? So, you have to know the characteristic of type 1 survivorship curve. Okay, what is the answer?
B then.
Okay,
B.
one answer B. The answer is B, correct. Okay, now let's see why A is wrong. Most offspring die young. This one is referred to
Three.
type 3 survivorship curve. Okay, there is a boom and bust cycle. So the boom and bust can happen related to type berapa? 1, 2, 3. Siapa ada perasan tadi? Yes, type 3. Sebab type 3 ni juga it related to R strategies. So R strategies usually organism that have type 3 survivorship curve. And one of the strategy ataupun characteristic of type 3 survivorship curve is usually they are very open to boom and bust. Okay, right. There is a constant probability of death. This one referring to
Type 2, madam.
type 2 survivorship curve. Okay, good. Okay, next. Which of the following would not be a density dependent factor? Not B. Density dependent factors that limit population growth.
A, madam. A.
B.
A.
The answer is A. Tsunami. Okay, sebab apa? Tsunami is
Natural disaster.
natural disaster. So natural disaster is under density independent factor. Okay. Increase in predation. Ni density dependent factor. Limit number of nesting site ni referring to referring to spaces atau territoriality. Okay, right. Stress syndrome. This one under?
Intrinsic factor.
Yes, intrinsic factor. Okay, right, good. Okay, next question. Which of the following are the correct strategies used by tiger and cockroach to control population size? Okay, what is the answer? Okay, first you have to identify which one is K strategy, which one is R strategy. Tiger is K ke R strategies?
Okay.
This is K strategies. Cockroach is insect. So, dia adalah R strategies. Okay, so once you know, then you have to look at the characteristic lah. So, what is the answer? Clutch size ni apa? Ingat tak? What is clutch size? Clutch size apa?
Offspring.
Number of offspring. Okay, good. So, what is the answer? A, B, C, D?
D. D.
Oh, ada
D.
jawab C, D, D, C.
Tadi.
Dadu. Okay. The answer is D. Okay, donkey. Right. So you can see large clutch size. Right. Jumlah anak yang atau number of offspring is higher. Tiger is K strategy. So they produce small number of clutch size. So ni salah dah lah. Providing intense parental care. This is memang strategy for tiger, K strategies. So these are for no or less parental care. This is our strategy punya karakteristik lah. Right? And yang lain-lain ni limited by density independent. Ni salah. Sebab K strategies limited by density dependent factors. Kan? Okay. So the answer is 2 and 4. Okay, next. Choose organism that has greatest biotic potential. Ingat, what is biotic potential? Okay. Tak apa, you can type your answer if you want to. Kalau tak nak cakap. Okay, what is your answer?
Madam. Housefly tu apa?
Housefly tu apa? Oh, lalat.
Lalat.
Okay, which organism has greatest biotic potential?
A.
Yes, the answer is A, because housefly is in insects. So insect is apa nak cakap tadi dah? Lupa dah. Insect is small organism, right? So they are having characteristic that under R strategies. Okay, so the strategies, one of the strategy is to maximizing their biotic potential. In other words, to maximize their reproductive success by producing a lot or large number of offspring. Okay, right. Next. Which of the following are true regarding the above figure? So first you have M curve, M growth curve, and you have N growth curve. So what is M? What is N? M ialah logistic growth curve. So N is exponential growth curve. Okay. Now look at the apa nama ni? Statement given. What is the answer? Okay, what is the answer? Semua betul. Okay, statement number 1. Cepat-cepat jawapan. Cepat, tak habis soalan nanti ni.
C, madam.
C, A,
C.
C. The answer is B. The answer is B. Okay, now let's see. First, N growth curve. N ni. Exponential. And growth curve may represents the world's human population. So secara dunia, satu dunia ni, adakah populasi manusia dah level off ataupun populasi manusia semakin meningkat? Jawapan dia masih lagi meningkat. World's human population still increasing. Kalau they are going to mention specific, India ke China ke, so they are approaching carrying capacity. So there would be S lah, kan? Okay. Size of population M meaning logistic growth curve is not influenced by density dependent factors. Ni salah. Sebab ingat ni, ada perkataan apa ni? Density dependent factor. So M is logistic growth curve. So kenapa dia jadi logistic? Because they are encountering environmental resistance, right? So meaning they are affected by density dependent factor like limitation of resources. Okay, so not ni salah lah perkataan sebab not. It is influenced by. Itu baru betul. Okay, right. 3. Rapid growth occur in N and may follow by a sudden death due to limited shelter. Rapid growth in N can follow by a sudden death due to limited shelter. So this is boom and bust. So ingat J shape ni can happen to be like boom and bust. Okay, so tu kena ingat. So steady decrease of growth in M as population encounters environmental resistance. So environmental resistance kat sini maksud dia halangan environment like limited of resources. Okay, so jawapan dia 1, 3 dan 4. Yeah. Okay, next soalan structure. Graph 4, graph in 4 figure 4 shows deer population in Walla Walla Island. You have number of deer over months. Okay, soalan pertama. Determine the carrying capacity of the deer population. So what is the carrying capacity of this population?
80.
Yang lain?
80.
Yes, the answer is 80. Right? You can see that the curve is slightly fluctuate above and below 80. So nampak ni. Ini yang kita belajar tadi. Graph will ataupun population growth will fluctuating a little bit slightly and below the carrying capacity. So the carrying capacity ialah 80. Maknanya Walla Walla Island can support up until 80 deers in the island with all the resources that available. Okay, right. Soalan kedua. What caused the deer population to decrease slightly from month 6 to month 7? What caused the deer population to decrease slightly from month 6 to month 7? Tengok balik kat sini. Month 6 to month 7. What caused the population of deer decrease slightly from month 6 to month 7? So you know that the carrying capacity is 80. So what caused the population to decrease slightly between month 6 to month 7 ni? Rasa-rasanya apa faktor dia? Masa month 6 tu binatang dia yang ada kat situ dah lebih kurang 90 lebih ekor. Carrying capacity 80. Lepas tu what caused it reduce slightly and back to 80 lebih kurang?
Competition.
Yes, very good. Competition. Ingat, resources yang ada can support 80. But now population size you ada dalam 90 lebih. So that will cause the resources available cannot accommodate more than whatever the carrying capacity can accommodate. So that lead to competition. Salah satu dia. Competition for what? Satu jawapan competition. Lagi? Ada orang boleh bagi jawapan lain? What else? Come on, cepat. Meta nak pergi kelas lagi ni. Competition betul. Lagi apa? Food. Competition for ataupun limited resources like food. Food is limited. So limitation of resources. What else? Dah dua. What else answer that can be accepted? Tak apa dengar, Fatihah. Food, space. Okay. Lagi? Jawapan dia ialah all the density dependent factors. Apa-apa jawapan under density dependent factors? Because you know the population size is increase. High density. So high density of population can cause all the factors tadi tu that lead to the slow growth or population will slow down or decrease. Okay, so competition for limited resources like food, nutrient, water, space, parasitism, spreading of disease, accumulation of waste, overcrowding. So ni semua adalah under density dependent factors that can be accepted. Okay, right. Macam tu tau soalan structure macam ni. Okay. Okay, next. Name the type of competition among the deer during the decrease of population. Type of competition among the deer.
Intraspecific.
Intraspecific.
Intra-specific competition. Sebab intra-specific competition is competition among individual of the same species. Soalan pun tanya among the deer. Kan? Okay, intra-specific competition. Okay. Alright. Next. Next question. You have two curve, P and Q. So P is J shape, right? Nampakkan kat situ bentuk dia. And Q is S shape curve. Okay. So you have number of individual versus time in minute in this case. Okay. Apa nama? Question A, and you can please read the question statement as well. Figure shows two type of population growth curve. So bila kata growth curve, maknanya ada dua je growth curve. S shape dengan J shape. Logistic dengan exponential. So first question. State one factor that caused curve P shifted to Q. Macam mana boleh faktor yang boleh menyebabkan curve P, okay, curve P jadi naik macam ni, naik kat mana ni? Okay. Naik, lepas tu level off. What factors that cause P to Q? Apa dia?
Cari yang kata titik itu.
Lagi?
Environmental resistance.
Encountering environmental resistance. Contoh? Contoh apa? Apa contoh environmental resistance? Limited resources. Lagi apa? So kesimpulan dia sama juga. Nampak tak, ada dua soalan keluar lebih kurang sama. Tanya benda yang sama. So this is related to density dependent factors. So kenapa population tu boleh naik and suddenly dia akan level off. Macam tu. Okay? Right. So presence of environmental resistance, limiting factors, competition, lack of food, nutrients, space, water, waste. So apa-apa yang berkaitan dengan density dependent factors. Okay. All right. Next, still using the same diagram. Calculate the growth rate shown by curve P. Curve P at minute 2.5. If the rate of immigration and emigration are equal, and birth and death are 220 respectively. Okay, dia suruh cari growth rate. Mana ni? Growth rate. So, apa formula growth rate? R equals to?
B minus D
B minus D
plus I minus
plus I minus E. Okay, kira lah sekarang. What is the rate? Ingat tulis formula dapat 1 markah. So you can see here the mark given to you is 2 marks over here. So tulis formula dapat dah 1. So jangan lupa tulis formula. Okay? Right. What is the answer? Okay, first what you need to find. You need to find what is the N, population size of curve P at minute 2.5. At minute 2.5 kat sini. So what is the number of population dia at minute 2.5? You dapat 250. So 250 ni you boleh guna untuk dapatkan apa? The birth rate and also the death rate. So R equals to B 200 minus D 20 over 250 because your data given here is not in the form of rate. Dia baru bagi tahu kelahiran 200, kematian 20. So, you kena dapatkan kadar dia dulu. Then you have to divide with the population size. And what does it mean by the rate of immigration and emigration are equal? Maknanya apa?
0.
0. I minus E is 0. So, what is your answer?
0.72.
0.72.
Yes, 0.72. You can see here. Writing formula 1 mark. Okay. So, ni 1 markah, ni 1 markah, ni 1 markah. Right. So, maximum 2 marks. Okay. Right. So, 200 divided by 20 over 250. Right. And plus 0 untuk I minus E. Then you get 0.72. So this is the growth rate for curve P at minute 2.5. So kadar pertumbuhan pada minit 2,5. Itulah kadar dia. Kadar dia 0.72. Okay, macam tu. Alright, next. Okay, still using the same diagram. Calculate the change of population size. Change of population size. Apa formula? Change of population size. Apa maksud change of population size?
dn over dt.
Yes, dn over dt. dn over dt. Okay, cuma you tak tahu nak guna yang mana satu ni. Equals to Rn ke? Rk minus n over k ke? Kan, you tak tahu. Okay, so calculate the change of population size shown by curve Q. Curve Q at minute 25. If the growth rate remain the same as curve P. Okay, baca soalan betul-betul. Calculate the change of population size by curve Q at minute 25. Sorry, at minute 25 kalau growth rate remain constant as P. Okay. Macam nak buat ni? Kita tengok gambar dulu. Okay, curve Q. Curve Q adalah logistik. Apa rumus change of population size for curve Q? dn over dt equals to R.
Rn k minus n over k.
K minus N over K. Okay. So first nak dapatkan apa? N dulu. N dekat mana? N at minute 25. So at minute 25, the population size ialah ni 1,500. So you dah dapat 1,500. Dia kata apa? R change of population size shown by curve Q at minute 25 if the growth rate remain the same as P. Growth rate remain the same as P. So growth rate berapa?
0.72.
0.72. 0.72 times 1,500. Lepas tu darab dengan K minus N over K. What is the carrying capacity of this environment? Tengok gambar. What is the carrying capacity?
1,500.
1,500. Sorry lah yang ni yang tak ada pen. 1,500 minus N. N you 1,500. Sebab at minute 25. Divide by K. 1,500. So, berapakah?
0.
0.
Yes, the answer is 0. Mana ni? Nampak tak? Walaupun tak guna calculation, you actually can know what is the growth rate here at minute 25. Because at minute 25, you can see that the curve is already level off at carrying capacity. Maknanya, the growth rate akan jadi ataupun the change of population will be 0. Tak boleh dah tambah tolak orang lagi ke apa ke, tak ada. Sebab you have already reached the carrying capacity. Okay, faham? This is question related to calculation. Okay. So macam ni lah kaedah dia. Okay. Right. Habis. That's all for chapter 12. Few exercise related. Okay. Any question?
No, madam.
No. Okay. So kalau tak ada soalan, I guess that's all. Alright. So, okay.